In order to subtract proper fractions with unlike denominators, let's first begin by looking at what a fraction is. So let's remember we have a numerator and we have a denominator for our fractions. And because we're talking about proper fractions, our denominators are going to be larger than our numerators, okay? So just a key reminder, numerators and denominators are utilized in proper fractions, and the numerator is less than the denominator. So now we're in a situation here where this problem, we're going to talk about unlike denominators. That means that the denominators are not the same, but that's perfectly okay because we can figure out what to do. So let's look at these two circles, for example. Okay, circle 1. And circle 2. Now in this first circle, there is no divisions. It's one complete circle. In this second circle, I'm going to draw these two lines here. Now, have I changed the amount that was in the circle? No, that is still the exact same amount. This is one whole here, and this one is also one whole. When we're looking at fractions and we're thinking about fractions, how many parts does it need? Well, this one only needs one part, whereas this one, in order to make that whole, you need 4 parts. All right, that is where the denominator comes from, saying how many parts you need to make a whole. Now, we can describe each individual part if we would like, but the denominator tells us how many parts we need to make a whole. Now, when we're looking at this, because it's one whole, I can easily make this first circle have the same amount of parts as the second circle. And I have not changed anything with the exception of how I divided this first whole. That's what we're going to look into as we begin to subtract proper fractions with unlike denominators. The first thing that we want to remember to do is to make the denominators the same. So let's write that down. Make denominators the same. And then we're just going to subtract our proper fractions exactly like we know how to do. So let's jump into the let's do this and let's try it out. Here we have a denominator of 3, and here we have a denominator of 6. We can see that these numbers are not the same, but we can easily make them the same by creating a chart, just like we did before, and figuring out our multiples that they have in common. We're specifically looking for the least common multiple, the one that they have in common. So here we go. Let's do some math here. Times 2 in that section. I should have put the lines first. Here we go. Times 3 times 4, and I don't even think we'll need to go that far, but let's put some numbers in. So 3 times 1 is 3, 3 times 2 is 6, and there we can already stop because we can see that now they are the same. All right. So what did we do in order to get 3 to look the same as 6, which is the second denominator? All we needed to do was multiply it by 2. So here we take this entire fraction and we bring it here and multiply it by 2. That means we multiply everything by 2, the top and the bottom. All right, that gives us 1 times 2 over 3 times 2. All right, and of course you can write your multiplication however you'd like to. If you'd like to use the dots or the parentheses, that's perfectly okay. When we work that problem out further, that gives us 1 times 2 is 2. 3 times 2 is 6. Because we do not need to do anything to this second fraction, we just bring it over, no problems. All right. Remember that this is a subtraction problem, so we're going to bring subtraction over here as well. And then we're bringing over our 3/6. So now we have 2/6 here minus 3/6. And we know how to work those out. That's just simple subtraction of proper fractions. So we subtract our numerators and we bring down that denominator. 2 minus 3 is -1. We bring over our 6, and that is what it's saying there. Our answer is -1/6. Let's see if we can prove this with a diagram. So what we have here in this first fraction is essentially, let's go with our circle. Oh, let's do a square or rectangle. Keep changing my mind. Okay, we have a rectangle and it has 3 pieces there, and we have one of the 3 pieces here for that first fraction. So this one says 1/3. And we want to subtract away 3/6 of a portion or an amount. So let's draw another one just to see what 3/6 would look like. So that means we have 3 parts out of 6 parts needed to make a whole. So let's divide this down into 6 parts first. Okay. In order to do that, we divided it now into 6 parts. We have 3 out of those 6. So that means that we have 1, 2, and 3. There we are. We have 3 parts there. Now here, before we even change it, we can see that this entire top row matches this entire top row. That's okay. But we want to take that entire row, plus we want to take an additional piece down here. Now, where are we going to get that additional piece from? There's nothing there for us to take. That's where we get into the negatives. So now you're thinking, okay, well, let's make sure that it's a -6. Well, does this shape here, this rectangle, look exactly the same as this one? Does it have the same number of parts? The answer is no. But can we make it look the same? Well, that answer is yes. If we divided this into 2 parts, hint, hint, 2 parts times 2, so that now we have this here and this here, we can see there that we have now a total of 6 parts. So that same 1/3 now accounts for 2/6 because it's 2 parts out of the 6, which definitely simplifies down to 1/3. So hopefully that makes sense there. Well, even with that 2/6 there, and I take the 3/6 here, you want me to take 3 pieces away from 2, that's going to leave me with owing that 1 piece there, or that -1 piece. So that's how we got -1 out of 6. All right. Hopefully that makes sense for you and you were able to follow through and able to understand all of the steps that we did there. I want you to pause for a moment now, and I would like for you to check for understanding. Welcome back. Let's work out this next problem. So first of all, are the denominators the same or are they different? Are we working with what type of fraction? What's going on here? Well, here we can see that we do have 2 proper fractions. And I know that they're proper because the numerator is less than the denominator for each of our fractions. All right, so we're dealing with proper fractions. Now we're looking at the denominators. The denominator here is 7. The denominator here is 5. So I can see that those are different. That means step number 1, make them the same. How do we do that? We do that by finding the least common multiple. So we're going to write our denominators out here, 7, 5, and I always like to make a little chart. It just makes it so easy to see exactly what you need to do for each one. I don't know how far we need to go, so let's do this. So this one is times 1, times 2, times 3, times 4, times 5, times 6, and we can go on and on and on, but hopefully we'll get to it before then. So here, let's go through our 7s. 7 times 1, let's use black. 7 times 1 is 7. 7 times 2, 14. 7 times 3, 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. All right, and we could go on if we need to, but I see a number that ends in 5, so I know at least one of those numbers will be a multiple of 5 here. So let's go. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. Oh no, let's add one more space because 5 times 7 is 35. All right, so we can see here now that we have a match. All right, 35's there. So that means we can turn both that 7 into 35, we can turn that 5 into 35, and make these have the same number of parts required to fulfill a whole. All right, so let's start with the first problem. Here, 3/7. What did we need to do to get that to turn to 35? Well, we had to multiply by 5. So we take this entire amount here and multiply by 5. Okay, that gives us 3 times 5 over 7 times 5. And we know, we're going to bring that down here so that I can work it out the other way. That's going to give us 3 times 5 is 15. 7 times 5 is 35. Perfect. Now we're going to work with our second problem. And I'm going to just use red for that one. That's okay. How do I make this 4/5 have a denominator of 35? Well, if we look at our chart here, for 5, we had to multiply by 7. So we're going to take this fraction and bring it over here and multiply by 7, okay? So that is going to give us 4 times 7 over 5 times 7, all right? 4 times 7 here is 28. 5 times 7 is 35. We remember that we are subtracting, so we bring our subtraction down now between our two problems, and we have 15 pieces minus 28 pieces. That's going to be our answer. So how do we get from, if we only have 15 parts and we need to take away 28 parts, can we do that? Well, yes, of course we can, but it's going to give us a negative answer. So let's put our answer there. Over 35. Oh my gosh, I did not write the in-between step. So let me erase that because I don't even want that. Our in-between step, we have to show all of our steps in order to subtract proper fractions with like denominators. We take the numerators and we subtract those there. There we go. And then that gives us our negative 13 over 35 as our answer. Because 1 is a prime number, it cannot be simplified with 35. So that's what we have there. That is our answer. I hope you were able to subtract proper fractions with unlike denominators. If you were, go ahead and give your box a check there. Happy learning!